Mine Economics, Management and the Law. Introduction. Finding an ore deposit and putting it into production as a mine requires the execution of many complex tasks, such as exploration and evaluation, planning, development, production, processing, reclamation. Also required as a team of technical experts with skills in many areas. Number one, drilling, modeling, explosives and blasting, ventilation, mapping, equipment selection, ground control, power system, waste disposal, and so forth. In this video, I will highlight the key points of mine economics, management, and law, and specifically with respect of those three topics. They directly influence the ability of a company to find a mineral deposit, develop a mine, and operate the mine profitably. The disciplines and practices of mine economics, mine management, and mining law are largely devoted to controlling risk and maximizing returns from the exploration of mineral deposits, exploitation of mineral deposits. Those risks and returns occur come into the position of to investors, mining company shareholders, governments, and residents of the area around the mine. Management and control of the risks associated with mining investments require special methods because the assets in a mining investment are more difficult to quantify than those in many other investments. The term gold mine is frequently used in a colloquial sense to describe an unusual good investment. Mine economics. This section addresses four topics related to the basic premises of the profitable exploitation of a mineral deposit. Number one, evaluation of mineral properties. Number two, mineral property feasibility studies. Number three, cost and cost estimation methods. Number four, investment analysis. Mineral property evaluation. The deposit must be characterized adequately and with the required degree of certainty. The extent of the deposit must be defined usually in terms of the amount of ore present. The quality to the quality or tenor of the deposit must also be defined, usually expressed for metal deposits as grade, the fraction of metal present, in milligrams per ton for precious metals, as a percentage for base metals. For coal, quality is characterized by the impurities present, specifically sulfur and ash, the heating value, and for metallurgical coal, the coking qualities. For industrial minerals, user requirements are often specific in terms of impurities and other properties, and standard expressions for quality are less common. Besides characterizing the quality of the deposit, the evaluation will also include an analysis of the legal status of the mineral holdings. Legal status will include determination of who owns the mineral or mining rights, who owns or controls the surface rights, who controls access to the property, and who owns the required water rights. Preliminary assessment will focus particularly on any characteristics of the deposit and its locality that may be problematic. Examples include deposits. Number one, in particularly remote locations. Number two, where permitting may be difficult. Number three, where local opposition may be extreme. Number four, where water, fuel, or electric power are expensive or unavailable in sufficient quantities. Number fifth, where the political climate is unstable. These preliminary assessments are often called adults, environmental, regulatory, social, and cultural, and so forth, and are described extensively in the literature. The requirements for accurate characterization of deposits are given in various national standards. Finally, it is important to remember that reserve risk is not always a function of resource risk. Modifying factors in the various standards are meant to account for the condition that should be considered when converting a mineral resource to an ore reserve. Mineral property feasibility studies. A feasibility study of a mining project is an appraiser of the commercial viability of that project, which accounts for A. Engineering, B. Economic, C. Permitting, D. Environmental variables. To control costs and to cater to the progressive increase in geological confidence and understanding of the modifying factors, feasibility studies are usually conducted in stages. Table 5.1, page 1, Criteria for feasibility studies. This table represents the criteria for feasibility studies. To reduce project failures, the foundations need to be properly laid. This starts with the stakeholders understanding the project life cycle versus the value of the impact of change and having a quality project evaluation report. Project evaluation management is challenged in keeping study groups focused and addressing the risk issues in a timely manner. Special review meetings are to be scheduled throughout the project. Cost estimation. Cost estimation is a part of every feasibility study. A mineral deposit should not be considered for development unless the estimated annual operating profit after taxes and other costs is sufficient to recover, which interest the cost of developing the mine and of closing and reclaiming it. One approach defines three types of feasibility study: conceptual or scoping, pre-feasibility, and feasibility. Table 5.1-2 and 5.1-3 show the specifications for the capital and operating cost estimates respectively in each type of study. You can see in next slides. Table 5.1-2 specifications for capital cost estimates in feasibility studies. This is the continuation of first one. Table 5.1-3 specifications for operating cost estimates in feasibility studies. Cost estimation. The correct compilation of a cost estimate requires consistency, attention to detail, and good sources of cost information. Many equipment suppliers have proprietary software for estimating capital and operating costs, which may often be used at no cost by prospective customers. For example, Caterpillar equipment costs can be determined directly from the company's Build and Code website, Caterpillar 2010. In addition, regularly updated cost data are available by subscription at the CostMine website, maintained by InfoMine 2010. Investment analysis. An investment analysis may be carried out as part of a feasibility study or as a separate effort. The analysis must consider the cost of the capital funds employed and the risk involved in the project. For any development project, investment of the required funds must be justified to the funding source. Several criteria may be used for analysis of investment. Some are relatively easy to calculate, such as the accounting rate of return and the payback or payout period. Other criteria are calculated using discounted cash flow methods, which are more complex. These include present value, future value, annual value, net present value (NPV), benefit cost ratio, and internal rate of return. Discounted cash flow methods require detailed and extensive calculations, and executing them by hand requires considerable skill and patience. Thank you. Please subscribe, like, and share.